The morning fog sat thick over the French countryside east of Arracourt on September 19th, 1944. Lieutenant Andrew Leiper, commanding Third Platoon, Charlie Company, 704th Tank Destroyer Battalion, couldn't see more than 75 yards through the grey soup that blanketed the rolling farmland of Lorraine. His M18 Hellcat sat hull down on the high ground north of the village, engine idling, 76mm gun trained eastward toward the German lines. The radio crackled. Movement detected near Lezey. Multiple contacts. Heavy armour. Leiper's gunner, Corporal James Mitchell, peered through his periscopic sight. Nothing but fog. The loader, Private Robert Chen, had already chambered a standard M62A1 armour-piercing round, but Leiper reached into the ammunition rack and pulled out something different. The casing was marked T4 HVAP, high-velocity armour-piercing, tungsten carbide core, muzzle velocity 3,400 feet per second. They received exactly one of these experimental rounds per month. Most crews saved them. Leiper had a feeling today wasn't a day for saving anything. The shell went into the breech. Mitchell adjusted his sight picture, and then, through the fog, shapes materialized, low, angular, moving in column formation down the road from Moncourt. German Panthers. 5 of them. Maybe 6. At approximately 1,200 yards, Leiper made a decision that would help define American tank destroyer doctrine for the remainder of the war. He didn't wait for the Germans to spot him first. He didn't wait for perfect visibility. He gave Mitchell the range. 1,200. The gunner laid the gun. Leiper watched through his commander's periscope as the lead Panther's turret began rotating. Slowly. Searching. The German commander had heard something, sensed something, but couldn't locate the threat through the fog. That rotation would take time. The Panther's hydraulic traverse moved at roughly 6 degrees per second. To swing 90 degrees toward Leiper's position required 15 seconds. Mitchell's manual traverse on the Hellcat moved at 24 degrees per second, 4 times faster. Leiper counted in his head. The Panther had detected them. The turret was moving. 8 seconds until that 88mm gun pointed at their position. Maybe less. Mitchell fired. The HVAP round left the barrel at speeds conventional ammunition couldn't match. The tungsten core screamed across 1,200 yards in just over 1 second. It struck the Panther's side armour at an oblique angle, just below the turret ring. The German crew never completed their rotation. The penetration was catastrophic. Ammunition cooked off inside. The Panther's turret lifted slightly, settled, and began burning. 7 seconds. From first detection to kill. The other Panthers scattered. Some reversed. Others tried advancing through the fog to close the distance. Leiper's Hellcat was already moving, racing to a new firing position 300 yards south. The other Hellcats in his platoon opened fire from different angles. The Germans couldn't track targets that moved this fast, shot this quickly, and disappeared before return fire arrived. By 9:15 that morning, Third Platoon had destroyed 3 Panthers without taking a single hit. The Germans withdrew in confusion. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What happened that morning near Arracourt wasn't luck. It was mathematics. Cold, brutal mathematics written in milliseconds and muzzle velocity. When an M18 Hellcat equipped with HVAP ammunition locked onto a German Panzer at 1,200 yards, the Panzer crew had approximately 8 seconds to respond before destruction became inevitable. 8 seconds. Not 8 minutes, not even 80 seconds. 8 ticks of a clock. In those 8 seconds, a Panzer crew had to detect the threat, identify its location, rotate their turret to face it, lay their gun on target, and fire. The Hellcat crew only needed to do one thing: pull the trigger. They'd already done everything else. To understand why this 8-second window existed, we need to go back to the fundamental design philosophies that created these two machines. The Panther represented German engineering at its most ambitious. When Hitler demanded a tank to counter the Soviet 34 in 1942, German designers created something magnificent. 100 millimeters of frontal armor angled at 55 degrees, an effective thickness exceeding 5 inches, side armor measuring 80 millimeters. The 75mm Quay 42 gun with a 70 caliber barrel that could penetrate 5.5 inches of armor at 1,000 yards. Point blank, almost 7 inches. This wasn't just a tank. It was a mobile fortress designed to dominate any engagement through sheer technical superiority. But that superiority came with costs. The Panther weighed 45 tons. Its Maybach HL-230 engine produced 700 horsepower, impressive until you calculated the power-to-weight ratio, 15 horsepower per ton. The complex interleaved road wheels, overlapping in 3 rows on each side, distributed weight beautifully, but jammed with mud and snow. The hydraulic turret traverse system, while smooth and precise, rotated at just 6 degrees per second at optimal engine speed. At lower RPMs, a full 360-degree rotation could take 90 seconds, sometimes longer. The transmission required 7 forward gears and constant adjustment. Every component was precision-engineered to exacting German standards. Beautiful, expensive, complicated. The American philosophy started from a completely different premise. In December 1941, the U.S. Army Tank Destroyer branch was created with a radical doctrine. They didn't want to fight, tank versus tank duels. They wanted to hunt. Their motto said everything. Seek, strike, destroy, find enemy armor, race to an ambush position, kill it, move before it kills you. Speed and firepower mattered. Armor didn't. When Buick started designing what became the M18 Hellcat in early 1943, they built it around a Wright R975 radial aircraft engine, 400 horsepower in a 17-ton vehicle, power-to-weight ratio of 23 horsepower per ton. Modern sports cars have about 15. The engineers gave it torsion bar suspension that could handle high speeds over rough terrain. They gave it an open-top turret to save weight. The armor measured 3/4 of an inch on the front, 1/2 an inch on the sides, thick enough to stop rifle fire and shell fragments. Nothing more. Every design decision screamed one word: speed. The Hellcat could hit 55 miles per hour on roads, 30 cross-country. The Panther managed 29 miles per cast hour on roads under ideal conditions, 15 cross-country if terrain wasn't too rough. But speed alone didn't create that 8-second death window. The gun did. The M18 mounted a 76mm M1A1 gun with a 52 caliber barrel. With standard M62A1 armor-piercing ammunition, this gun fired rounds at 2,600 feet per second. At 500 yards, it could penetrate 3.9 inches of flat armor. At 1,000 yards, 3.3 inches. Those numbers mattered because Panther side armor was just 1.7 inches thick. A Hellcat could punch through Panther side armor at virtually any combat range. But standard ammunition struggled against that massive frontal armor. The thick, sloped front plate of a Panther could deflect standard 76mm rounds even at close range. German crews knew this. Panther doctrine emphasized frontal assaults, where that armor advantage was decisive. Then came the HVAP round, high-velocity armor. Piercing ammunition entered limited distribution in September 1944, limited being the key word. Tungsten carbide was scarce, critical war material in desperately short supply. Each tank destroyer and Sherman with a 76mm gun received approximately 1 HVAP round per month. 1. But that single round changed everything. The T4 HVAP, designated M93 after February 1945, weighed 18.9 to 1 pounds and measured 32.6 inches long. It left the gun at 3,400 feet per second, 800 feet per second faster than standard ammunition. At 500 yards, It could penetrate 6.2 inches of armour at 30 degrees. At 1,000 yards, 5.3 inches. The Panthers' side armour, 1.7 inches, might as well have been paper. This created a lethal equation. At 1,200 yards, an HVAP round took approximately 1.1 seconds to reach its target. The round flew faster than sound. The Panther crew heard the gunfire and the impact almost simultaneously. No warning, no time to react to the shot itself. The only chance was detecting the Hellcat before it fired. And here's where those 8 seconds came from. German Panther crews in September 1944 operated with specific engagement protocols. When a commander detected a threat, he had to identify its location, call it out to his crew, and initiate turret rotation. The gunner had to acquire the target through his monocular sight, lay the gun for range and deflection, and wait for the commander's fire order. This process, even for well-trained crews, consumed time. The turret traverse speed was the bottleneck, 6 degrees per second at engine speeds of 2,500 RPM. To rotate 90 degrees, 15 seconds. 45 degrees, 7.5 seconds. But combat rarely involved perfect 90-degree angles. Let's say a Panther crew detected a Hellcat at 1,200 yards, 45 degrees off their current gun position. The turret had to traverse 45 degrees, 7.5 seconds. But detection wasn't instant. Through the fog, through the terrain, the commander needed perhaps half a second to identify the threat. Call out the target, another half second. The gunner needed time to acquire through his optics. Another second. Lay the gun. Another second. Now we're at 10 seconds. And this assumed everything went perfectly. No confusion, no hesitation. Perfect crew coordination. American Hellcat crews didn't have these limitations. The manual turret traverse might sound primitive compared to German hydraulics, but it was faster, 24 degrees per second. More importantly, Hellcat doctrine emphasized getting into position before firing. They didn't detect the enemy and then start moving their gun. They moved to a position where the gun was already pointing at where they expected the enemy to be. When Lieutenant Leiper's platoon set up north of Arracourt on September 19th, they'd positioned their Hellcats with guns oriented eastward along the likely German approach route. When Panthers appeared, the Hellcats didn't need to traverse. They needed to aim. That's a crucial difference. Aiming involved minor adjustments, 5 degrees, 10 degrees at most. At 24 degrees per second, those adjustments took less than a second. The Germans called this American tactic Sprungweiser Überfall, jumping ambush. Hellcats would race to a position, halt, fire multiple rounds, then sprint to a new position before German crews could respond. The speed made them impossible to pin down. During the Battle of Arracourt, which lasted from September 18th to September 29th, the 704th Tank Destroyer Battalion perfected this technique. They operated with Combat Command A of the 4th Armoured Division under Colonel Bruce Clark. The Germans had numerical superiority. The 5th Panzer Army deployed approximately 107 Panthers and 75 Panzer IVs, plus 80 assault guns, total armoured strength of 262 vehicles. Combat Command A had roughly 70 medium and light tanks, plus 36 Hellcats from the 704th. On paper, the Germans should have won. They had more tanks, better tanks, by conventional measures, thicker armour, more powerful guns. But Arracourt became a killing ground for German armour, not because American equipment was superior, because American tactics exploited German weaknesses. The morning of September 19th started the pattern. The 113th Panzer Brigade, equipped with brand new Panthers straight from the factory, pushed north toward American positions. They advanced in column formation, confident their frontal armour made them invincible. The thick fog that morning reduced visibility to under 100 yards in places. German doctrine said this favoured the attacker. Close the distance. Negate. American artillery and air support. Use superior armour in close-range slugging matches. Lieutenant Leiper's Third Platoon was positioned on high ground, with perfect fields of fire into the valley below. They'd arrived before dawn, set up in hull-down positions where only their turrets were visible, oriented their guns eastward, and they waited. When the Panthers appeared through the fog at approximately 1,200 yards, Leiper's gunner had maybe 2 seconds of target acquisition before firing. The HVAP round struck home. The lead Panther died. The column stalled. Confusion rippled through the German formation. Other Panthers tried to return fire, but they couldn't locate the Hellcats through the fog and smoke. Their turrets rotated slowly, searching. 720 turns of the hand wheel for a full rotation if the hydraulics failed. Even with power traverse, it was like fighting with your hands tied. The Hellcats fired again. Another Panther disabled, then another. The Germans tried advancing to close the range where their armor advantage might matter. But advancing uphill through fog toward an enemy you can't see is suicide. American artillery observers called in fire. 105mm shells from the 66th and 94th Armoured Field Artillery Battalions started landing among the German column. The Panthers withdrew. First engagement of the day. 3 Panthers destroyed, 0 Hellcats lost. Time elapsed, approximately 5 minutes. This pattern repeated throughout September 19th. German commanders sent Panthers forward. Hellcats tore them apart. At the village of Lezey, Charlie Company of the 37th Tank Battalion, supported by Hellcat platoons, ambushed a German thrust. The Germans lost 11 Panthers in less than an hour. American losses, 2 Sherman tanks. What made this slaughter possible was that 8-second window. Every time a Panther detected a Hellcat, the clock started. Identify. Communicate. Traverse. Acquire. Lay. Fire. 8 seconds minimum. Usually longer. Meanwhile, the Hellcat needed 1 second, maybe 2 if conditions were poor. Fire. Displace. The mathematics were brutal. In the time it took a Panther crew to bring their gun to bear, a Hellcat could fire 3 rounds, reverse behind cover, and be racing to a new position. The Germans couldn't land a hit on targets that moved like that. On September 22nd, the battle intensified. The 11th Panzer Division and 113th Panzer Brigade made a coordinated push. Over 60 Panthers participated. This was supposed to be the knockout blow, overwhelm the Americans through sheer mass. The Panthers advanced at dawn through morning fog. Again, visibility was terrible. But again, American crews had positioned themselves overnight. Hellcats sat on reverse slopes, hull-down positions where only the turrets were visible. As Panthers crested hills, Hellcat crews aimed for the thin belly armor exposed when German tanks tilted forward. Then, as Panthers tried to reverse away from the kill zone, Hellcats raced around flanks at top speed and hammered them from sides and rear. The battlefield turned into a graveyard. 23 Panthers destroyed by sunset. The German counterattack collapsed completely. The final tally for the Battle of Arracourt was staggering. The 704th Tank Destroyer Battalion claimed 53 Panthers destroyed or disabled. They lost 7 Hellcats. That's better than 7-1. Overall, German losses exceeded 140 tanks during the battle, with at least 86 Panthers confirmed destroyed. American tank and tank destroyer losses were fewer than 30 vehicles total. The Germans had sent their newest, most powerful tanks with experienced crews, and they lost catastrophically. One captured German after-action report stated, "American tank destroyer tactics are ruthlessly aggressive. They refuse direct engagement with our frontal armor. Instead, they exploit speed to attack from positions we cannot defend. Our turret traverse cannot match their maneuverability. By the time we bring guns to bear, they have already fired and relocated." Another German report, this one from 5th Panzer Army Intelligence, analyzed the problem more bluntly. The American M18 presents a tactical challenge we cannot solve with current doctrine. Our Panthers possess superior armor and firepower, but these advantages are negated when the enemy controls engagement geometry. The time required for our crews to detect, identify, and engage fast-moving targets exceeds the time required for enemy crews to destroy our vehicles from flank positions. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. That 8-second window wasn't just about turret traverse speed. It was about everything: crew training, tactical doctrine, equipment philosophy, target acquisition time, communication delays, human reaction speed. The Germans had built their tank force around the assumption that superior engineering would dominate battlefields. Thicker armor, better guns, more powerful engines. On paper, this made sense. In practice, it created slow, maintenance-intensive machines that couldn't adapt to American tactics. The Panthers' hydraulic turret traverse was supposed to be an advantage: smooth, precise, easy to control. But it was tied to engine speed. At low RPMs, traverse speed dropped dramatically, and Panthers frequently operated at low engine speeds because the Maybach engine overheated under sustained use. This created a vicious cycle. Push the engine hard, risk mechanical failure. Run the engine conservatively, sacrifice turret traverse speed. American tankers who examined captured Panthers couldn't believe the design choices. One technical intelligence report from Major General Isaac White's unit testing program stated, "The Panthers' turret traverse is unacceptably slow for fluid combat operations. Our crews can rotate their turrets approximately 4 times faster using manual traverse. This speed advantage enables multiple engagements before German crews can respond." The report continued. Additionally, Panther crews exhibit limited visibility when hatches are closed. The gunner's monocular sight provides inadequate battlefield awareness. The tank commander must verbally guide the gunner to targets, adding communication delays. American tank destroyer crews, with better vision devices and faster traverse, consistently achieve first shot capability. First shot capability was everything. Whoever fired first in tank combat usually won. The Germans knew this. Their doctrine emphasized long-range engagements where their superior guns could kill American armor before getting close. But doctrine meant nothing when American tank destroyers refused to play by those rules. Hellcats didn't advance toward entrenched Panthers. They maneuvered to positions where Panther armor didn't matter: side shots, rear shots, ambushes from unexpected angles. Every engagement was designed to negate German advantages. Speed enabled this. A Hellcat could travel 3 miles in approximately 3.5 minutes at maximum road speed. A Panther needed over 6 minutes. Those extra minutes meant Hellcat crews could shoot, displace, and be setting up their next ambush while German crews were still trying to figure out where the first shot came from. The fog at Arracourt worked in America's favor, precisely because it negated German long-range advantages. Panthers couldn't use their superior guns at 2,000 yards if they couldn't see 2,000 yards. Close the visibility to 75 yards, and suddenly that 88mm gun was irrelevant. What mattered was who detected threats first, who got their gun on target first, and who fired first. Hellcat crews won all 3 races. They detected threats first because they were positioned in known good observation points, waiting. They got guns on target first because they'd pre-oriented their turrets along expected approach routes. They fired first because their doctrine emphasized aggressive engagement. No hesitation, no waiting for perfect conditions. Enemy identified. Gun laid. Fire. German crews, operating under different doctrine, hesitated. Identify the target, confirm it's not friendly, estimate range, adjust for target movement, wait for commander's order. That hesitation cost seconds. In tank combat, seconds were the difference between living and dying. The HVAP round amplified all these advantages. With standard ammunition, a Hellcat might need 2 or 3 hits to penetrate a Panther from the side at 1,200 yards. The first round might not penetrate. It might ricochet. The crew would need to fire again, adjust aim, fire a 3rd time. Each shot took time, maybe 3 seconds per round, 9 seconds total. That gave German crews time to respond. But with HVAP, 1 round was enough. Penetration was almost guaranteed if the hit connected with side or rear armor. Fire once, destroy the target, move. The Germans never got those extra seconds to respond. This is why American commanders hoarded HVAP ammunition. 1 round per month was absurdly inadequate. Tank Destroyer battalions pleaded for more. The tungsten shortage made it impossible. But even with limited quantities, the psychological impact was enormous. Panther crews knew American tank destroyers might have HVAP rounds. They couldn't know which ones. This uncertainty forced German crews to be cautious. That caution slowed their response times, made them hesitate, gave Americans even more advantage in that critical 8-second window. The mechanical reliability contrast made everything worse for the Germans. Those beautiful precision-engineered Panthers broke down constantly. The final drive, the gear system connecting engine to tracks, was the Achilles heel. German engineers had designed it for a 35-ton prototype. Then they kept adding armor and equipment until production models weighed 45 tons. The final drive never got redesigned for the extra weight. Result? The average Panther final drive lasted about 150 kilometers before catastrophic failure. That's 93 miles. American mechanics examining captured Panthers were shocked. Hellcat drive systems routinely went thousands of miles between overhauls. The Maybach engine caused constant headaches. 700 horsepower sounds impressive until you learn that engine ran at the absolute limit of its design capacity just to move the tank. German crews called it temperamental. Aluminum engine blocks cracked under stress. Fuel injection systems clogged. Cooling systems overheated in summer and froze in winter. Maintenance manuals specified crews needed to warm up the engine for at least 30 minutes before moving in cold weather. 30 minutes, sitting, in one spot making noise while waiting for your tank to be ready. In combat, that got you killed. Then there were those beautiful interleaved road wheels, brilliant for weight distribution. Disastrous in practice. Mud and snow packed between the wheels and froze solid overnight. Crews woke up to find their 45-ton tank completely immobilized. The only solution was lighting fires under the wheels to melt the ice, a process taking hours and announcing your position to every enemy within miles. German records from 1944 show Panzer divisions reported an average operational readiness rate of 42% for their Panthers. On any given day, less than half were ready to fight. The rest were broken down, waiting for parts, waiting for repairs, or being cannibalized. The 5th Panzer Army that attacked at Arracourt started with 120 Panthers. 41 broke down before making contact with American forces. Mechanical failures, not enemy fire. Compare that to Hellcat reliability. The 704th Tank Destroyer Battalion maintained operational readiness above 85% throughout September 1944. When a Hellcat broke down, which was rare, the crew could often fix it themselves with basic tools. The radial engine was simple, reliable, and shared parts with aircraft engines. Spare parts were everywhere. The suspension rarely failed. The transmission was basically a truck transmission, easy to maintain and repair. This reliability gap meant German commanders couldn't trust their equipment. Planning an attack? Assume half your Panthers won't make it to the start line. Conducting a withdrawal? Assume more tanks will break down than get destroyed by enemy fire. American commanders faced no such constraints. Their Hellcats worked. This confidence enabled aggressive tactics. Push hard, take risks. If something breaks, you can fix it or get a replacement quickly. The Germans couldn't match that tempo. Every major brought offensive ground to a halt, not because of enemy action, but because the machines simply stopped working. At Arracourt, this pattern was obvious. After the initial attacks on September 19th failed, German commanders needed time to reorganize. Not because American resistance was overwhelming, because their Panthers were breaking down faster than they could be repaired. September 24th brought another German push. The 111th Panzer Division, reinforced with fresh Panthers, attacked American positions near Bézange. The attack began at dawn. Within 2 hours, 16 Panthers sat disabled, 8 from American fire, 8 from mechanical failure. The operational Panthers withdrew. The disabled ones sat where they stopped, waiting for recovery vehicles that never arrived. German recovery doctrine required specialized Bergepanzer vehicles to tow 62-ton tanks. Those recovery vehicles were often unavailable. Crews had to abandon their Panthers, destroy them with demolition charges to prevent capture. All that expensive German engineering left burning in French fields. The 8-second death window applied to more than just the moment of engagement. It infected every aspect of German armoured operations in the fall of 1944. Reconnaissance suffered. German panzer divisions lacked adequate scouting units. The 5th Panzer Army had no integral reconnaissance battalions. They were forced to advance blindly against Americans whose positions were shrouded in fog. American units had dedicated reconnaissance squadrons. The 25th Cavalry Squadron, attached to 4th Armoured Division, included 48 M8 armoured cars. Fast, mobile, equipped with radios. These scouts identified German positions hours before Panthers got close. This intelligence advantage meant American commanders knew where Germans were concentrating. They could position Hellcats in perfect ambush locations before attacks began. When Panthers finally arrived, they rolled into kill zones. The Germans tried adapting. After the initial disasters, Panther commanders started operating more cautiously. Advance slowly, stop frequently to scan for threats. Never expose your flanks. This caution reduced their tactical effectiveness. A Panther moving slowly covered less ground, supported fewer attacks, became predictable. American crews learned to anticipate German caution. If Panthers were moving slowly, carefully, they were scared. Scared enemies make mistakes. They bunch up for mutual support. They take predictable routes. They telegraph their intentions. Hellcat crews exploited every mistake. On September 26th, Combat Command A repositioned to defensive positions around Arracourt. The Germans probed these defenses throughout the day. Small attacks, company-sized elements, testing American strength. Every probe met the same response. Wait until they commit. Let them get close. Open fire from multiple positions simultaneously. The Germans couldn't handle the coordination. American tank destroyers, tanks, and artillery worked together seamlessly. Radio communication was excellent. Fire direction was precise. Infantry support was immediate. The Germans, by contrast, struggled with coordination. Panzer brigades were new formations thrown together without adequate training. Crews hadn't worked together. Company commanders barely knew their battalion commanders. Radio discipline was poor. One captured German radio transcript from September 27th shows the chaos. A Panther company commander was trying to coordinate with his battalion, requesting artillery support. The artillery battalion couldn't identify his position. The Panther commander gave grid coordinates. The artillery battalion said those coordinates put him behind German lines. The Panther commander insisted he was in the correct position. 5 minutes of confusion followed. By the time anyone figured it out, American Hellcats had already engaged the cantled Panther company from concealed positions. 3 Panthers destroyed. The company withdrew without ever receiving artillery support. This wasn't isolated. German after-action reports consistently mentioned communication failures, coordination problems, and units operating without proper support. The Americans faced fewer such problems because they'd trained together. The 704th Tank Destroyer Battalion had been attached to 4th Armoured Division since July. 2 months of operations together. They knew each other's procedures, radio frequencies, and tactical preferences. When Colonel Clark, commanding Combat Command A, needed tank destroyer support, he radioed Captain Thomas Evans, commanding Charlie Company. Evans knew exactly what Clark wanted before being told. Position your Hellcats here, cover these approaches, engage on your initiative, no micromanagement, no confusion, just mutual understanding born from experience. The German command structure was more rigid. Panther. Company commanders waited for orders from battalion. Battalion commanders waited for orders from brigade. Brigade commanders waited for orders from division. This hierarchical system created delays. By the time orders filtered down to the men actually fighting, tactical situations had changed. American tank destroyer doctrine emphasized initiative at the lowest levels. Platoon commanders like Lieutenant Leiper could make engagement decisions without asking permission. See a target. Determine if you can kill it without taking casualties. Kill it. Report afterward. This decentralized command philosophy was faster, more flexible, and better suited to the chaos of armored combat. The 8-second window existed because of accumulated American advantages. Faster turret traverse, better crew training, superior tactical doctrine, more reliable equipment, better intelligence, tighter coordination. Each advantage individually might seem minor, 6 degrees per second versus 24 degrees per second in turret traverse. That's just 18 degrees per second difference. But multiply that across every system, every decision, every engagement, and the cumulative effect was overwhelming. German Panther crews weren't incompetent. They were trapped in machines and doctrines that couldn't compete with American methods. By September 29th, the Battle of Arracourt was effectively over. The Germans made one final massive push. Over 60 Panthers committed to breaking American lines. It failed completely. The Panthers advanced into prepared positions. American artillery hammered them. P-47 Thunderbolts from the 405th Fighter Group arrived overhead when fog lifted. The aircraft struck German columns from above. Bombs, rockets, machine gun fire. The Panthers scattered. Those that survived air attack ran into Hellcat ambushes. The kill zone extended for miles. Burning Panthers dotted the landscape. Crews abandoned their vehicles and fled on foot. Some Panthers ran out of fuel before reaching American lines. Others broke down mid-attack. The few that got close enough to engage were destroyed by concentrated fire. The final accounting was devastating. Of the 262 German tanks and assault guns deployed, 86 were destroyed outright. 114 were damaged or broken down. Only 62 remained operational at month's end. The 4th Armoured Division's Combat Command lost 25 tanks and 7 tank destroyers during the entire battle. As a division, 4th Armoured lost 41 medium tanks and 7 light tanks during all of September. Casualties were 225 killed and 648 wounded. German casualties exceeded 3,000 killed and 3,000 captured, plus all those destroyed vehicles. The Battle of Arracourt became a case study in how tactical situations and crew quality matter more than technical specifications. German Panthers were superior tanks, by conventional measurements, thicker armour, more powerful guns, better optics. None of it mattered when American crews controlled the engagement geometry. The 8-second death window created by HVAP-equipped Hellcats at 1,200 yards was just the most dramatic example of a broader truth. You don't win by building the perfect weapon. You win by building weapons that work, getting them to the battlefield, and using them smarter than the enemy uses theirs. The psychological impact on German tank crews was profound. After Arracourt, captured Panther crewmen described feeling hunted. One interrogation report quotes a Panzer commander. "We could not see them until they fired. We could not traverse our guns fast enough to engage them. We could not catch them when they withdrew. Fighting American tank destroyers was like fighting ghosts. They appeared, they killed, they vanished. We felt helpless." Another captured report from a Panther gunner was more direct. "The Americans have Leiter, learned to kill us from positions we cannot defend. They strike our sides and rear where our armour is thin. By the time we rotate our turret to face them, they have already displaced. I saw 5 Panthers destroyed in 10 minutes. None of our crews saw the enemy until after being hit. This psychological defeat was as important as the physical one. German tank crews had entered the war in 1939 and 1940 with a sense of invincibility, superior training, superior tactics, superior equipment. The Blitzkrieg victories reinforced this confidence. France fell in 6 weeks, Poland in 1 month. Early victories in Russia seemed to confirm German supremacy, but by September 1944, that confidence was shattered. American tank destroyers could kill Panthers reliably. American infantry had bazookas that could penetrate rear armour. American artillery was everywhere, coordinated and deadly. American air power dominated the skies. German tankers who'd once felt invincible now felt vulnerable. The HVAP ammunition became legendary among German crews. They didn't know how rare it was. They didn't know American tank destroyers received only 1 round per month. All they knew was that sometimes American guns punched through armour that should have been impenetrable. This created paranoia. Was that Hellcat loaded with standard ammunition or HVAP? You couldn't know until it fired. If you guessed wrong, you died. So German crews treated every Hellcat as potentially HVAP equipped. That meant extreme caution, longer engagement ranges, more hesitation, all of which gave Americans even more advantage. American commanders recognized the HVAP shortage as a critical problem. Fourth, Armored Division's after-action reports from September repeatedly requested increased allocation. HVAP ammunition has proven decisively effective against German heavy armour. Current allocation of 1 round per gun per month is grossly inadequate. Recommend minimum allocation of 5 rounds per gun to enable reliable engagement of Panthers at combat ranges. The Army Ordnance Department acknowledged the request. Tungsten shortages made increased production impossible. Priority went to aircraft engines and cutting tools, not tank ammunition. The scarcity continued through the end of the war, but even with limited HVAP, American tank destroyer doctrine had proven itself. The skeptics who'd called the M18 a death trap in 1943 were silent after Arracourt. The lightweight tank destroyer with thin armour had destroyed heavy German armour at favourable exchange rates. Speed, reliability, and intelligent tactics defeated heavy armour and powerful guns. This lesson informed American armour development for decades. Don't chase maximum armour thickness. Don't obsess over gun size. Build machines that work, that crews can maintain, that tactics can exploit. The Germans never solved the Hellcat problem. They tried deploying Panthers in larger concentrations, thinking mass would overcome American advantages. Didn't work. More Panthers just meant more targets. They tried improving reconnaissance to detect ambushes earlier, but they lacked the vehicles and training for effective scouting. They tried changing tactics, advancing more slowly and carefully. That just made them predictable. They tried modifying Panthers with faster turret traverse. Too little, too late. Production priorities went to building more tanks, not improving existing designs. By the time proposed improvements could have been implemented, the war was over. The final months of the war in Europe saw Hellcats continuing their hunt. After Arracourt, 4th Armoured Division pushed east toward the German border. The 704th Tank Destroyer Battalion went with them. In November, they fought through Lorraine in terrible weather. In December, the Battle of the Bulge erupted. German forces launched a massive offensive through the Ardennes. 4th Armoured Division raced north to relieve surrounded American forces at Bastogne. The Hellcats went too. During the drive to Bastogne, they encountered more Panthers. The 8-second rule still applied. Detect, engage, destroy. The Germans couldn't stop them. In January and February 1945, the advance continued into Germany itself. The Hellcats crossed the Rhine in March. They fought through the Ruhr pocket in April. By May, when Germany surrendered, the 704th Tank Destroyer Battalion had been in continuous combat for 11 months. Their final kill tallies were impressive. 53 Panthers confirmed destroyed, unknown numbers of other German armour. The battalion lost 21 M18s during the entire war, some to enemy fire, some to accidents and mechanical failure. The exchange rate remained heavily in American favour. Post-war analysis vindicated the tank destroyer concept. The U.S. Army studied the European campaign extensively. One conclusion stood out: tank destroyers employed, according to doctrine, achieved kill ratios exceeding 7-1 against German armour. The M18 Hellcat proved particularly effective due to speed, reliability, and firepower. Crews reported high confidence in their equipment and tactics. Another study focused specifically on the HVAP ammunition. High-velocity armor-piercing rounds enabled American 76mm guns to engage German heavy armor at ranges previously considered impossible. The Tungsten carbide core provided penetration values 50% greater than standard ammunition. Despite severe shortages, HVAP ammunition had disproportionate tactical impact by forcing German crews to operate more cautiously. The 8-second window that existed at Arracourt in September 1944 was really a window into American military philosophy. Europeans, particularly Germans, had a long tradition of military excellence. They studied war as an art. They refined tactics through centuries of experience. They built weapons with meticulous attention to engineering perfection. Americans came from a different tradition: industrial mass production, pragmatic problem-solving. If it works and we can build enough of it, that's good enough. The Hellcat embodied this philosophy perfectly. Was it the best tank destroyer that could have been built? No. Better designs existed on paper. Thicker armour would have been nice. A 90mm gun would have been better. Fully enclosed turret would have protected crews from weather and fragments. But those improvements would have added weight, reduced speed, complicated production, and delayed deployment. The M18, as built, was good enough to do the job required. Destroy enemy armour, support American advances, win the war. It accomplished all three missions brilliantly. The Germans never understood this pragmatic approach. They kept chasing perfection. After the Panther came the Tiger II, even heavier and more powerful. After the Tiger II came paper designs for Maus and E100 series super heavy tanks, bigger guns, thicker armour, more complex engineering. These wonder weapons consumed resources while producing minimal battlefield impact. Germany built 1,350 Tigers total. The Maus project produced 2 prototypes, neither saw combat. Meanwhile, America built 2,507 Hellcats, 50,000 Shermans, 476,000 bazookas. The numbers told the story. Wars of attrition favour the side that can replace losses. Germany couldn't replace Panthers destroyed at Arracourt. The factories were working at maximum capacity. Allied bombing disrupted production constantly. Raw materials were scarce. Skilled workers were scarce. Transportation was disrupted. Getting new tanks from factory to frontline units took months. America replaced destroyed Hellcats within weeks. The production pipeline never stopped. Supply ships crossed the Atlantic constantly. Trains brought equipment from ports to frontline depots. Trucks delivered it to combat units. The logistics machine worked efficiently. This logistical superiority meant American commanders could be aggressive, lose a tank, get a replacement, expend ammunition, more arrives tomorrow, break down, parts are available. German commanders had to be conservative. Every loss was potentially permanent. This conservative mindset infected every decision. Should we attack? What if we lose too many tanks? Should we withdraw? What if tanks break down during retreat? The paralysis was strategic. By late 1944, German armoured forces were shadows of their former strength. not from combat losses alone, but from the cumulative effect of mechanical unreliability and irreplaceable losses. The Panther represented everything Germany did wrong in World War II: over-engineered, over-complicated, over-expensive. German engineers designed it to be the ultimate tank, superior in every measurable specification. On paper, it was. But war isn't fought on paper. War is fought in mud, in rain, in forests, in towns with narrow streets, by tired soldiers who need equipment that works when they're cold and scared. The Panther failed those soldiers. It broke down. It caught fire. It got stuck. It ran out of fuel. That beautiful German engineering became a liability. The Hellcat represented everything America did right, simple enough that a mechanic from Nebraska could fix it with a wrench, fast enough to avoid fights it couldn't win and hunt down enemies it could kill, cheap enough to build in huge numbers, most importantly, designed around clear tactical doctrine. Speed and firepower beat armor and complexity. American engineers didn't try to build the perfect tank destroyer. They built a good enough tank destroyer that worked reliably and could be mass-produced. Good enough plus reliability turned out to be the ultimate weapon. By May 1945, German Panzer divisions were finished, not because they'd been destroyed in dramatic battles, but because their vehicles simply stopped working. American Tank Destroyer Battalions maintained combat strength throughout the war because their vehicles kept running. The production capacity gap sealed Germany's fate. America could absorb losses and keep fighting at full strength. Germany couldn't. Every Panther destroyed was irreplaceable. Every Hellcat destroyed was annoying. That difference compounded over time until German armoured units operated at 30 or 40% strength, while American units stayed at 90% or higher. The tactical flexibility proved decisive. American crews learned to fight smart rather than fight fair. They used Hellcat speed to dictate engagement terms. They avoided Panther strengths and exploited weaknesses. German doctrine was rigid: advance, dominate through superior firepower and armour, hold ground. American doctrine was fluid: find, flank, fire, flee, repeat. Fluid doctrine beat rigid doctrine when equipment matched tactics. The Battle of Arracourt became the template. American tank destroyers destroyed German heavy tanks at remarkable ratios, not through technological superiority, but through tactical superiority enabled by speed and reliability. Those lessons applied across every battlefield in Western Europe, from Normandy to Germany. Fast, reliable, good enough vehicles used intelligently beat slow, unreliable, theoretically superior vehicles used conventionally. The 8-second window that existed when Hellcats locked onto Panthers at 1,200 yards was just the most dramatic example. That window existed everywhere, in target acquisition time, in mechanical reliability, in logistical support, in crew training, in tactical flexibility. Every system, every decision, every engagement. Here's the final lesson. The $55,000 Hellcat beat the $300,000 Panther because American planners understood something fundamental. You don't win wars by building wonder weapons. You win wars by building weapons that work, building enough of them, and using them smarter than the enemy uses theirs. The Germans built a masterpiece. The Americans built a winner. When the war ended in May 1945, it was Hellcats racing through Germany while Panthers sat broken beside the roads, monuments to the failure of over-engineering. That 8-second window proved lethal because it wasn't really about 8 seconds. It was about everything those 8 seconds represented. American industrial might, pragmatic engineering, superior tactics, better training, reliable equipment, effective logistics. When all those advantages combined, the result was inevitable. German crews had 8 seconds after a Hellcat locked on at 1,200 yards. 8 seconds to detect, identify, communicate, traverse, acquire, lay, and fire. They never had enough time. The Hellcats made sure of it. Speed, reliability, and tactical intelligence defeated. Armor, firepower, and complexity every single time. That was the lesson of Arracourt. That was the lesson of the entire Western European campaign. The Germans never learned it. They kept building heavier tanks, mounting bigger guns, adding thicker armor. Meanwhile, American Hellcats kept hunting, kept killing, kept winning. The mathematics were simple and brutal. 8 seconds isn't enough time when your enemy only needs one. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.